Hi, I'm Leandro Facchinetti, and let's write some code / create some hardware together, shall we? Today what we have on the menu is a new project. We are going to use some Arduino to create a MIDI controller that I will be able to step on, so there will be a couple of buttons and also an expression pedal. Super fun stuff. I'm planning on using this when I'm playing the guitar, so I can activate looper pedals using software, of course. I will plug everything into Reaper and I will be able to use probably Super 8, the looper that comes with Reaper. So I will activate the looper using the pedals, and I will have an expression pedal for things like wah and volume, that sort of thing. It would be fun. So disclaimer, I have very little experience with hardware and Arduinos and whatnot, so we'll be learning together. We will start with the unboxing of everything I bought. It's not too much. It's like the bare bones, the minimum you need to get a project. So this is a new view. You can see my desk. Isn't that fun? So first item, an Arduino. It's upside down. An Arduino. So I got the Arduino Micro. There are several flavors of Arduino and many knockoffs, many other brands that do Arduino compatible boards. And some of these other brands are actually better than Arduinos in some aspects. But why did I choose this one? It's probably not the most common one you're going to find in other projects. You're probably going to find things like the Arduino Uno. But I decided for this one for two reasons. First, it says back here that it can act as a keyboard or a mouse or other HID USB devices. What that means is that supposedly I will be able to connect this to a computer and it will show up in the computer as a MIDI device, which is super cool because if I didn't have this kind of Arduino, if I went with like the Uno, the most common one, the one you probably think of when you think of Arduinos, if I went with that one, I would need to run some special software in my computer to translate the serial information coming from the Arduino into the computer and translate that into MIDI. But in this case, it doesn't work like that. I will just plug this into the computer and supposedly the computer will think, oh, this is a MIDI device connected. Great. So that's reason number one. Reason number two is that the Arduino Micro is small, as the name suggests, and it also happens to be slightly cheaper, but not by a huge margin, not as much as you would expect. So let's unbox this guy. I find it very calming to watch unboxing of stuff that I care about, like Arduinos. So that's why I left the unboxing for the stream. Also because I didn't actually have the time to work on this project before the stream. And then you see how lousy I am with manual work. Just trying to get the box open is already painful, let alone when we get to soldering. Am I right? So let's see what comes in the box. And this is an actual Arduino. It's not a knockoff. And if I remember correctly, this was actually built in Italy, and they make sure that their employers receive wages that make sense and all that sort of stuff. So that's a good thing. I appreciate that. I prefer to do business with them. Right, so that's the little box. And then what is in the box? This is a beautiful board. Some stickers, whatever. Thank you for choosing and supporting the Arduino community. Sure, I'm glad to support you guys. And they think about the environmental impact of their packaging. Cool stuff. But this is not like a manual, so there won't be instructions of how to use the Arduino here. We'll have to figure it out ourselves. Okay, so let me get that stuff out of the way. And now for the board itself, look at this. This is beautiful. It comes with pins that allow the Arduino to just attach to a breadboard. Now, I don't happen to have a breadboard. I was in the shop and I gave the list of things that I wanted, and the guy forgot about the breadboard. I forgot about the breadboard, so I don't have a breadboard. Whatever, I don't think I'll need it. The project is gonna be so simple. So look at this Arduino Micro or Micro. I think it's Micro. Micro, whatever. So there is a little USB port here, which will be used for loading our programs. And also, when the project is done, I will plug this into my computer, and this is how I will connect the MIDI device to the computer. And Arya is here. Hey Arya, great to have you here. And zoom out a bit. I cannot zoom out, but I can lift the arm that is holding the camera. Does that help? Do you think that looks better? Right, so I wanted to show as much detail as I could. And now there is a mic cable on the way. Okay, now it's not there anymore. Great. So all these little, well, pieces of metal here are connectors, and they are labeled. And the labels are tiny because this is such a small board. But I can find one pin here that is labeled. I gotta leave soon, but wanted to check this out. Hey, great to have you here. So there is this tiny label here saying 5 volts. That's important. That's like the source of energy. It's like the battery. If we want to power something, as we will want to power the expression pedal, we are going to put the power on this pin, 5 volts. And then 2 pins to the right, there is the ground. Ground is also, well, super important. The power is going to come from 5 volts and go into the power going through the pedal. And Bo is here. Hey, Bo. Great to have you here. And Ashkun, sorry, I don't know how to pronounce your name. Sahu is here. You two have been working on something. Yes, we all, Bo and Arya and I, have been working on many things at this point. Probably too many. Okay, so 5 volts is super important, and ground is also a big deal. And then there are all these other ports that are labeled with numbers. These are numbers that we are going to use in our code to identify data coming in. We'll have a button that will be connected to one of these little pins with a number, and in the code we'll say, I want information coming from the button that is attached to port number 5, for instance. And then there are these other inputs here that are labeled A0, A1 up to A5. These are analog ports. So buttons will be connected to these ports that are called digital ports, and the expression pedal will be connected to one of these analog ports, because the expression pedal is not just on or off. It can be in any state in between. So it will be analog. I will receive values between 0 and 1023, I think. So that's the Arduino. We are going to start with the Arduino today, and I think that the plan is I'm going to unbox the rest of the stuff, and then we are going to connect the Arduino to the computer. We are going to load some sketch project, some very simple project, and we'll try to get some LEDs to flash, or maybe this board does not come with a LED. I know that some Arduino boards like the Uno come with an embedded LED that you have control over with the code, and I think that this one also has it. I think that this little LED here is something that we can control with software. And then there are other LEDs like these two that we don't control with software. They just indicate whether I am loading a program into the board, or if any kind of serial connection is happening, any data is traveling on the wire. So that's the Arduino. That's the core or the brain of the project. Next, super exciting. These are the push buttons that we are going to be using. I will be stepping on those, and I tried to find the kinds of buttons that you would find on stomp boxes, and I couldn't, they were out. But I think that this may actually be better, because I'm not going to be like on stage stepping on this with no care at all. I will be here at home on my studio. I will be stepping on this like probably barefoot or just not that hard at all. So this may actually be a better option, because I think that this may be quieter. Those regular stomp boxes kind of buttons, they are definitely heavy duty, but they make a lot of noise when you push on them. And there are two kinds of buttons. Well, there are plenty of kinds of buttons, but there are two main kinds of buttons that you would use in a project. And then these two kinds are the kinds of buttons that when you press, it stays pressed, so it remembers that. And then when you press it again, it comes back up. Or there are these kinds of buttons that you just press and it comes back up. And again, on stomp boxes, usually you have this first kind of button that you press and it remembers that, and then you press it again and it comes back up. And that's all fun and games. But first of all, they were out of this kind of button on the store when I went. And I think that it may be better to actually have this kind of button, because in software, you can always write a program that will notice, oh, the button has been pressed, but I will keep the state. I will not do anything on the release. So I can, with software, simulate one of those buttons that remember their position. And then I have more flexibility. I can let the button just be on and off, or I can have it remember its state. And I don't have this right now, but I could just have some LEDs. I didn't buy LEDs, but I could have some LEDs to indicate state on the board if I wanted. And I think that that is more flexible than a button that remembers its state. And Aria says, would be cool to mount those on a guitar. Yes, I have seen people who have modded their guitars with MIDI controllers, essentially. Like a MIDI controller, kind of a small MIDI controller, like glued to the body of the guitar. And that could be fun. But that's not what I'm going to build, I don't think. Not right now, anyway. And Sahu, can I pronounce your name that way? Do you want to like indicate the spelling of your name? But in any case, you were saying, where would I find these buttons? Well, when I lived in the US, I could only find them on Amazon or on stores like Adafruit. So in essence, I would have to buy them online. But for these guys, I actually was able to go across town here in Porto, where I live, in Portugal, and I was able to go to an electronics supplier store, and I bought this there. Yeah, and then I bought the Arduino there. All the things that I'm going to show you now, I bought there. So coming up next, we have the expression pedal. This is for wah, volume, I don't know, all fun stuff. I imagine that I will actually write some code to also control OBS with MIDI, so I will be able to step and change scenes. Currently, I have keyboard shortcuts, but they are not super reliable, especially because I have an M1 Mac. The keyboard shortcuts sometimes don't work, but a MIDI controller, that will always work. So I'll be able to hands-free switch scenes, which is kind of cool. And maybe with the expression pedal, I can like control the volume of something. Maybe, I don't know. I don't think that the expression pedal will be useful for OBS, but it will be useful for like playing the guitar and even playing the keyboard, I don't think. Where are my scissors? Okay, so this is like the cheapest expression pedal money can buy. It's an M Audio EXP. Let's get the box on the shot, and I will make a fool of myself trying to open this thing. My wife said, like, do you want help on this stream? I think you need help to open all this stuff, and especially when you get to soldering. I think you need help, Leandro, and I think she's right. They don't make it easy for me. I will cut myself live. There will be blood, you all. There will be blood. What is your idea, Bo? Oh, yeah, okay. The idea that we were talking about yesterday, where you have an Arduino not as a sensor. Essentially, I'll have the Arduino as a sensor. It will be picking up signals from the buttons and from the expression pedal and sending it to the computer. But Arya has this other idea that is the opposite. The Arduino would be actuators. I think that's the name of the thing. The Arduino would be controlling stuff in the real world. So again, bunch of paper, don't need that. And as far as I understand, this kind of device, an expression pedal, is essentially a potentiometer. It is something that, like a knob on any kind of electronic device, except that it's controlled with your foot, but it's the same principle. So let me show you what I mean. Okay, some more plastic. Oh, I don't think I will be able to actually show the potentiometer in there because it's well hidden in the case, which I guess is a good thing because it makes the thing safer. And like if you are on stage and you spill something on top of your pedal board, I think that this guy may survive. So there is a button here on the, essentially one of those knobs that I was talking about, but this is not, I don't think, the potentiometer. This is probably like for something like to adjust how stiff the thing is, how hard it is to push. I don't notice any difference when doing this. And there is also this switch here for M audio or other. I have no idea what that does. But here's what I do know. Check this out. The way that you connect the expression pedal to, well, anything that you want to connect an expression pedal to is with this connector, which is like a stereo TRS, tip ring sleeve, so TRS, a typical TRS connector, the same kind of connector you would find on your stereo system. But this is not, there is no audio traveling through this. This is not an audio cable. What this is just a connector with 3 parts. And then we can connect one part to the ground. Typically, you would connect the sleeve to the ground. And I'm not so sure about this, but I think that I need to connect the tip to 5 volts or the ring to 5 volts. So one of the two. I'm not sure that it matters really. I don't think it does. In any case, you connect one of the two to the ground. You connect the sleeve to the ground, one of these two to 5 volts, and the other you connect to one of those little analog input thingies. And if you connect the expression pedal that way, then when the pedal is all the way up, it is not going to let any current through, and the analog input is going to read 0. And when you push it down, it's as if you were twisting one of those, you're rotating one of those knobs, and then 5 volts is going to go through, and all different voltages in between 0 and 5 volts. So that's the connection we are going to make. Ground, 5 volts, and then in the middle, we are going to connect the analog input. And then there is this M audio and other situation here. I'm not sure which one we need to use. I think that one of these situations is the regular expression pedal, as I just explained. The other situation is going to be something maybe M audio specific, where the tip and the ring are going to be in different positions. I don't know. We'll figure this out. And something that I should have gotten, but I forgot, and the guy at the store also forgot. I told him I wanted, and he just forgot to put it in the basket. But it was one of those situations where there is a counter and a guy, and I had to speak to the person and say what I wanted, and he forgot about it. I forgot about it, but I should have a jack for this, like to connect this to something, and then I could put some wires into the Arduino, but I didn't get that. And maybe it is for the better, because I can always just cut this wire and take apart the little 3 wires that I expect to find in there. We'll see. I expect to see 3 little wires in there. I will cut it. We'll see. So that's the expression pedal. And then Bo says, Don Worrell and John Tidy and that mastering guy brushed up on a recent podcast. Yeah, I heard that. I heard that while I was going to the store to pick up all this stuff, I was listening to that podcast, and it was about distortion, and it was interesting. And Arya says, I have the same expression pedal, a bit finicky, but great. I use it as a mod wheel sometimes because I'm a bad keyboard player. Yes, I think I will map. We can do this with software. We can decide how we are going to map and which MIDI messages are going to be sent using software. I think I'm going to, at least to begin with, I think that the expression pedal is going to send mod wheel messages, just because it works well with things. If I am playing the keyboard, it works well with things like Decent Sampler and Sorzendo and the Spitfire Labs stuff. And tomorrow we'll be doing a stream on orchestration, and I will be using the BBC Spitfire library, and that is using the mod wheel. So I think that this is going to send mod wheel kind of signals. I love how your friend Arya sets up his Reaper templates. Okay, I'm glad that you like my friend. Oh, that's the sensitivity knob for calibration with other pedals. Oh, I didn't know that. Okay, I will probably have to play around with this to get something good into the Arduino. With different pedals like pitch shifter, you sometimes have to calibrate it so it doesn't shift to fractions of a semitone away from where you want. Oh, if I come in here, I'll probably find 2 wires and a shield, maybe. And in that case, I will just like twist the shield into a little wire and solder that into the ground of the Arduino. Right, okay, so to find out all these things, like which wire is connected to what and what happens if I turn the pedal up and down, essentially, to debug the system, I need one of these guys, a multimeter. Back when I was in university, I used one of these, and when I was a child, my father made me use one of these for several things. But I'm not a pro, so I bought one that is supposed to be automatic. In other words, if I understand correctly, if I am doing stuff like with the Arduino, which is not power hungry and there is not a lot of current going through, I will not be able to blow the fuse on this one, which is something that I don't think I did when I was at university, but I remember many people did in the physics lab. And here is a manual that I will read at some other point, because I definitely need a primer on how to use a multimeter. And here is the user manual in English, which may be better. I think I prefer going to the source instead of the Portuguese translation. But yeah, right, multimeter. The debugging tool of hardware. And I will be able to tell which wire is connected to what. Oh, and this is great. I don't see any multiples here, so I don't have to select the right range to measure something. I just have to select like voltage, resistance, current. Great. Bo says, do you have a multimeter? They are very useful when doing projects like this. Yes, I do. And Jim is here. Hey, Jim, great to have you. I hope you enjoyed the ride. This is a beginner sharing their discoveries in the land of electronics. Lots of fun stuff. What else? Well, probably not today, I don't think, but I will get my hands dirty with one of these guys, soldering iron. I am so bad doing things like this, as you can tell on my performance here, unboxing things. If I burn the house, I will not be surprised. I'll probably burn myself. That's okay. Burning myself is acceptable. But I'll probably burn the whole neighborhood with this. And this is like a cheap, as you can tell by the price tag, this is a cheap soldering iron. I told the guy, I don't care about it too much. I won't be working on this all day long. It's just a one-off. Or maybe a new career. I don't know. If we really enjoy this, it may be a new career. I like this. Look at this. Isn't this cute? So I don't have to put it on like the desk and burn the desk. I can put it here, though. It is kind of cheap, I will admit. Next. This is kind of cute. I didn't know this thing existed. I don't think I used this ever before. But when you solder something wrong, and I'm sure I will, this is like a syringe. So you put the soldering iron on top of the solder that is wrong and you want to undo. So it's going to melt, and then you just suck all the solder from the mistake. That is super cool. I used to like use a stick or paper for that. Then plier. That's not interesting, but I'll need it. Wire. And solder. Let's get the show rolling. That's it. That's all I have for now. So that's all the gear I bought. I don't have a breadboard and I don't have the connector. But other than that, I think I pretty much have everything you would need for this sort of project. I was terrible at soldering a few weeks ago. Then I found some tutorials on YouTube. Let me know if you want me to point you to one. Definitely, yeah. If you want to send it via email, I don't think you can post links here on the chat. But if you want, you can send me via email, and the email is this. And then you will be able to send links. A good soldering station is the one thing I would suggest to upgrade. Hackles are very nice. Okay, I'll look into that. But okay, so let's do this. I have the Arduino. I have a little USB cable that is already connected to my computer, and let's plug this guy in. All right, I should be back with the audio. Oh man, I explained a lot of stuff without the audio. Oh, it was when I went to the computer screen. Oh, god damn it. That's too bad. Thanks for sticking around, and I will go over what I talked. So, yeah, I guess it is your fault, Jim. No, my USB... it's not even the cable. The audio... My audio device, my H5, just disconnected from the computer without actually turning off, which is kind of weird. My digital to audio... my analog to digital converter just went down. Weird. Whatever. We'll deal. We'll go over this again. So what I had to do was to select the right board that I have, and I had to select the right port for this. Then the program is written in a language that kind of resembles C++, but it's not quite. It is a simplified version of C++, which is great because C++ can be a complicated language. And programs in Arduino are called sketches. So that's why I went with the example. It's a sketch, it's a program. And I'm doing the one that's blinking a LED. And an Arduino program comes with you have to define two functions. One is the setup. And for people who know JS effects and have been following me on in the channel, on my streams, then the setup function is pretty much like the init block in JS effects. It's a function that is going to run once when the board loads. So when you power it, when you connect it to the computer, it's going to run the setup function. And then the loop function, as the name indicates, is just going to keep running. And so Arduino is going to turn on, it's going to run the setup, and in here you have to do some configuration, and then it's going to run the loop function, and when the loop function is over, it's going to restart running the loop function and running the loop function over and over until you turn off the power. And then what we are doing here is we are saying there is a LED that comes in the board. You don't have to connect any wires or anything. It's just a LED that is in the board. It's this little LED right here. And you have to always say, if you want to use any kind of pin, so any buttons that you connect to a pin or any LEDs that you connect to a pin, you have to say, I want to use this pin in this mode, because some pins can act as inputs or outputs depending on what you connect to it. So if you connect a button, it's an input. If you connect a LED, it's an output. And you have to say, I'm using this pin in this mode. That's why we have this line here. And that's the kind of thing you would find in the setup. Maybe you would also find some sort of mathematics and computations that you need to do to begin with. But in essence, you're just initializing things. And of course, with the built-in LED, it's always going to be an output, but you still have to say what mode you are operating on. Now I just want to make sure that my audio is still coming through. Yes, you can still hear me. Great. And in this loop, what we are doing is, in this pin that is the LED that is built in, I want to send some energy. Then I'm going to sit for 500 milliseconds, stop sending energy, sleep for 500 milliseconds. And then this is just compiling the program to check that it works. This is actually sending the program to the board. And after I set up all my board, module, and port, everything worked because I checked the program, it was okay, and I uploaded the program. And check this out. The little LED here is now blinking faster because I changed, I think that out of the box, when you plug the Arduino into the computer, it kind of loads with the program that is going to blink a LED, blink this built-in LED. But it was blinking every second, and I changed that to every 500 milliseconds. So now let's change that to 100 milliseconds and upload this, and the LED will start blinking faster. At least that's the hope. See, it is blinking faster, so we are actually loading new software into the board. And it's kind of amazing how much space we have. We only have 28 kilobytes for our whole program, so it cannot be too big. And we only have 2K for our memory, so our variables. Everything that we store needs to live in this small space. Now, I think it will be okay because there's not a lot we want to do. We only want to have 4 buttons and maybe extend to a little more later. 1 expression pedal, maybe 1 more expression pedal later, so I can control both the expression and the volume, the mod wheel and the volume at the same time. Could be fun. All right. Anything else that I missed? Oh, no. It's just the sound that was gone, and now it is good. And Tormi Van Koo is here. Hey, great to have you. Thanks for being here. All right, so we loaded a sketch that is blinking the LED. That's cool because it shows that everything in the process is working, but let's try to make this Arduino act as a MIDI device. So there is something for MIDI USB. I don't want the Arduino to be sending MIDI to some other hardware using a MIDI cable. I want this to show up as a MIDI device for the computer. So that's why I'm saying MIDI USB. I'll also put Arduino in the mix. And there is this library called MIDI USB. There is another library called MIDI controller library something. Yes, that one. Or actually has been updated and changed name to Control Surface. So yeah, there are 2 libraries that people use to turn Arduinos into MIDI devices that connect to the computer via USB. The first way is to use this library called MIDI USB. The second, I think that's probably the only 2 ways that people do this, is with this Control Surface library that is in fact using the MIDI USB library under the hood, but the MIDI USB library, as you can see in the documentation, is very bare bones. We only read or send MIDI and we flush the bus to actually send the data if it has been buffered. But that's all. Very bare bones. In this Control Surface library, it is going to use this other library, but it's going to give you facilities like I want to have things like LEDs to indicate something, or I will have something like a push button. And then there will be functions, or not exactly necessarily functions that you call, but there will be all these helpers here, all this infrastructure for you to just say at a very high level, I have a button connected to port 8, go ahead and do your thing. While here, we would have to do everything with our bare hands. So I think that to begin with, I'm going to start with this library because I want to get at least the essentials going. If that works, then we may consider using this library, though it may be overkill for our project because it is such a simple project. But it may take care of things that we may not want to deal with, like debouncing buttons and that sort of thing. So if you don't know what I'm talking about, when you press a button, it is going to go from not pressed to pressed, but in between, there is a split second when it is in this in-between state. And it can be like off, and then on, off, on, off, on, off, on, off, on. On, off, on, off, on, off, off. And you don't want that kind of signal to be triggering whatever is you're triggering with the button. So if you have like a looper connected to the button, you don't want the looper to react to all this variation in between. You want it to be off, then on, then off. That's called debouncing the input. So this is going to take care of all these kinds of things that can be useful. But let's start with the simple stuff, which is this MIDI USB library. To use this library, I will have to install it because I don't think it comes with Arduinos. So I will have to go manage libraries. I think that's where I want to go. Yeah, so under tools, there is this manage libraries situation, and this is essentially just an interface for going to the GitHub repository for this library and downloading it to the right place. But it's a nice, convenient thing for me to do. So I'll look for MIDI USB, that one. And I want the latest, probably. And a nice thing to notice about this is that it's not going to work with any board. So I had to look into this before I bought the board, because if I got an Arduino Uno, for instance, it may not work with this library. I don't think it does. Yeah, it needs to be these kinds of cores. And I think that the Arduino Uno does not have that kind of board. Right, so I think that the library is installed now. Let's look for USB MIDI, or it was MIDI USB. Yeah, it is installed. Great. So because it is installed, I can import the library into my sketch. And I can do that with this line. So this line is bringing the library into my sketch. And the example that they have in their documentation is doing a lot more. Oh, I guess I probably don't want to do it on this sketch, because this sketch is blinking a LED and that is working. So I'll save as. I'll call this maybe test MIDI. And then on this one, I'm going to import the library, and then I will need to do some stuff to set the library up. Not in this case, actually. Cool stuff. I don't have to do any kind of initialization here on the setup for the MIDI library. There is some pins, because you can see that this example project actually has some push buttons. We'll get to that in a moment, but right now we don't have any push buttons. There is even a potentiometer here to the right, so our pedal here it works essentially the same as this thing. See, it's connected to an analog input, just as I was describing. And it's also connected to the ground via the breadboard, using this path going there and then this way. So it's connected to the ground. And it's not connected to 5 volts. It's connected to this other port that is not necessarily sending 5 volts. It's sending the reference voltage that you need. So I guess in essence, what we are doing is pretty much this example. But let's not start with that. Let's start simpler. So we don't need to do anything to set the library up. We would need to set the buttons up. But let's not go there yet. Instead, what I want to do is to just send some MIDI. So the same way that I was blinking the LED, I'm not going to blink the LED anymore. I'm going to send the MIDI message to the computer. So it's going to be like, pretend that I pressed key C4 and then I release the key after 1 second. So it's going to be similar to the LED example in principle, except that it won't be blinking a LED. It will be sending messages. So to send a message, I think that this is what I need to do, but there may be some other auxiliary functions I can use real quick. Yeah, so MIDI note on. And maybe I can copy these 2 functions because they look so convenient. But I do not like the new lines. Let's see if my sound is still working and everything. When you push record, a lamp turns on telling people silence, we are recording. Oh, if only baby would read that sign. Am I right? So let's look into the functions we just copy and pasted to understand what they're doing. They're just auxiliary functions we can call from anywhere. And then it receives 3 arguments. The first argument is the MIDI channel. MIDI messages need to occur in a channel that goes, usually they are numbered from 1 to 16, but I believe that in this context, they are going to be numbered from 0 to 15. So that's because you may want to have multiple MIDI devices attached to the computer, like multiple keyboards, and you want the different keyboards to work with different instruments. So in Reaper, you can route the MIDI channels that way. Then pitch, it is going to be a number that represents the note, like C4, and the velocity with which you press the key. So I'll call note on with channel 0. The pitch, I will send a C4. Do you know what a C4 is? Because I don't. Off the top of my head anyway. So C4 MIDI. Let's know. I just want the MIDI note numbers. Note numbers, yes, that sounds more like it. So I'll send a C4 that is 60 in MIDI. Yes. So I'll send note, I think I need to send note 59. I think it will be indexed by 0. And I think that in this document, it's indexed by 1. No, it is indexed by 0. So I actually want to send note 60. And for the velocity, I will go with 127. So the strongest or the highest velocity you can hit a key with. And then let's look at the body of the function. So it's going to create a MIDI message. It is just a way to pack in a data structure. It's going to pack all this information we sent. So in the MIDI specification, note on is represented with this number. This is the sequence of ones and zeros that you have to send to communicate note on. Then this is the way you communicate the channel. So in essence, you are just putting together the number that is coming from here, like channel number 0, and you're putting it together with part of a message that needs to, with part of a data structure that will be understood by the send MIDI function. And this is just a convention of numbers that you have to specify. So the same way that a C4 is 60, this is note on. And what this is doing is something that we touched on in previous streams. This is a bitwise OR. So it is going to look at this number, and it's going to check it bit by bit, and it's going to do a inclusive OR. So if either one is a 1, the output is going to be 1 for that bit. Then the pitch is going to be part of the message, and the velocity is going to be part of the message. That's pretty straightforward. So all this line is doing is creating a variable called note on, which is kind of interesting because they're naming the variable after the function itself. So cool stuff. This is just a MIDI message, a packet. And then to actually do something with that packet, we use the MIDI USB send MIDI message, and that is going to send a message to the computer. And then similarly for the note off, almost everything is the same except that instead of being 9, this is 8, and this is in the MIDI specification. You can always look up on the internet the same way I did with the note numbers. You can always look up what the MIDI messages that you can send and their codes and everything. So instead of blinking a LED, I will send a note off, and we don't have a pin in this situation, so the setup function will be empty, and we may even be able to remove it, but I won't. So something interesting about this is that we can send a velocity for the note off, which is like how fast or how strongly you are taking your finger off of the keyboard. Most MIDI devices don't have a notion of velocity for when you're removing your finger, but you could, in theory, depending on the kind of device. So in this case, I will just send a 0 as the velocity. I think that's the convention for most MIDI devices. So let's send this to the board. And if it works, it doesn't, because it already showed some sort of error in the code. Oh, but it's done uploading. So maybe it was just a warning, I don't know. We can check the logs because I saw something red there. But we can see that something is happening here because we don't see this LED blinking anymore. So it's no longer running the program that it was a moment ago. And this other LED is blinking. And if I understand correctly, this LED represents communicating with the computer. So this is both when you're loading a program. I wasn't watching, but I think that this LED blinked when we were transferring programs to the board. And this LED is also, I think, going to blink when we send MIDI messages because it's speaking to the computer. And then there is the no LED. The no LED is still on. Now let's go to Reaper. I will open another Reaper instance. I want to make absolutely sure that you will be still able to hear me no matter what. So I'll just mute this. I don't want to hear anything coming from here. And let's go to my MIDI devices, and hopefully an Arduino is going to show up. There is my Arduino. Let's enable this for all kinds of messages and for output as well, just for good measure. Not that I think we are going to send any kind of MIDI message to the pedal board, but we could. And if we had things like LEDs connected to the pedal board, then we could control the LEDs from Reaper, sending MIDI messages. So cool stuff. All of that looks good. Then let's enable this for recording and go to MIDI, all inputs, all channels. And let's put a MIDI effect on this track. Control MIDI. I can already see that MIDI messages are coming because of spikes here, but let's show the logs. And I was expecting to see MIDI messages showing up here, and I did see a MIDI message once. It spiked here, but oh, see? MIDI messages are coming through. But check this out. The MIDI messages are coming through in batches. We have to wait a lot, and then we receive note 6 C velocity 127, so that's a note on, and then a note off, and then a note on, and a note off, but they are coming in batches. So effectively what's happening is the LED here doesn't necessarily represent that I'm going to send the message right away. There is a buffer of MIDI messages, and they're being buffered. And then when the buffer reaches a certain size, then it sends all the messages in a batch. And this could make sense in some contexts. Maybe you want to look at the state of the world with all your buttons before you send a bunch of MIDI messages for on and off situations all at once. But in our case, we want to send the messages right away. So I am going to find the MIDI USB flush function, and I'm just going to call it right after we send our note ons and note offs. We could also paste this here, and then every note we ever send is going to cause a flush. But I don't think I want to do that, at least not right now. So let's upload this version. And it's still giving me a weird error when it's uploading, but it is succeeding. It's done uploading. And then we can clear the logs. And now the messages are coming through right away, 1 second at a time, just as we intended. Great. That's a great hello world of MIDI. Blinking LED makes a good tremolo pedal with an LDR. That was my first Arduino project. Cool. Yeah, I know that LEDs are used even for things like compressors. You can have a LED and then you can have a photosensitive something. I don't remember the name, but then the LED is going to excite this photosensitive something, and there is a sort of decay to the way it picks up light, and then compression is smoother because of that. It's the optical compressors, but yeah, way above my pay grade. I've read and watched a ton of videos on the subject. I have not seen anyone explain all the small details as well as you. I really appreciate it. I really appreciate it that you are here and saying all these nice things to me. You are too kind. I deleted because I saw you already answered. It's on the screen, great. Then you can virtually program Arduino as a DMX receiver instead of the DMX protocol. Just it drives some lights by tracks driven by a MIDI track on Reaper that's aligned with the music on tracks. I have no idea what a DMX receiver is, but I suppose it's something that you use to control stage lights? Yeah, it seems like it. So yeah, if it speaks MIDI, you can connect an Arduino to your computer using the USB cable, and you can speak MIDI to your computer via the USB cable, and that's super convenient. I don't want to have a MIDI interface on the way. It's just annoying. But I can use the outputs from the Arduino. We are not going to have any outputs in this project, but we could have outputs from the Arduino that are sending MIDI messages. You can speak MIDI, and I mean the MIDI cables. You can wire things here in the Arduino so that on the other end, you are going to have a MIDI cable that you can plug into something. And if the DMX receiver receives messages like that, then yes, you could use an Arduino as a weird MIDI interface. But I don't know why you would want that, because, right, you could just use a MIDI interface. What? It's that easy? I thought it would take so much more code. I'm gonna have to try this sooner or later. Oh, photoresistors. That's the name of the photosensitive kind of thing. Yeah, light-dependent resistor. All right. Yeah, okay. So that's the long and short of this is that we already have a way to send MIDI messages. So now all we gotta do is connect one of these little buttons to the Arduino in one of these ports and have the pressing of the button activate this function instead of just being time-based, right? Because it's still running, it's still sending messages to Reaper, see? Messages are coming through. So all we gotta do is write a little bit of code. Well, we have to literally wire the thing for the button to be connected to the board, but then we need to write a little bit of code so that when we press the button, we send the message. So we're going to do that right now, and then we are going to wrap it up. So let's connect this and have a button actually do the button thing. And then next time, it is going to be on Thursday, we are going to connect the pedal, the expression pedal, and we may even solder some things. It will be a lot of fun. So let me get this out. Yeah, I was thinking maybe I could use the wires from the multimeter to do this connection, but it seems like no, because this is like super protected in a case, which I guess makes sense. I shouldn't be using the multimeter cables to do this sort of thing. And I don't have a breadboard. I wish I had a breadboard, but I don't. So let's fumble around with this and hope for the best. So I'll switch back to my other camera, and I hope that that does not cut my audio. Okay, the audio is still coming through. Great. So let's get a little bit of wire here in this situation, and I can zoom out, I suppose. And the connection is going to be like this. So I said that there are these kinds of buttons that remember their state, and that I don't have one of those. I have a button that is just sending to the Arduino the message of I am off, I am on, or I am being pressed, I'm not being pressed. So in this kind of button, this is probably the simplest button you can think of. It's like a light switch on, well, your house lights. It's like a light switch. It's just on or off. And then the way the connection is going to work is we're going to connect one of the sides. It doesn't matter which. This kind of electronic component is symmetrical as far as I understand. So we are going to connect one of the sides to the ground and one of the sides to an input on the Arduino. Okay, so I guess a good rule of thumb for electronics is you never work with wires and anything when it's powered. So I'm going to turn it. I don't want to blow anything. I mean, the Arduino is meant for like kids, so it's typically kind of hard to blow up an Arduino, even if you do something silly, like if you connect the power directly short-circuiting into the ground, it is still going to have some sort of protection, usually. And especially when you're powering it using the USB cable. The USB specification says that if you're powering something via USB and there is a short circuit, the power source, in this case my computer, should stop sending energy, so it should stop sending power. So the USB specification says that my computer should not be able to blow up an Arduino. But in this split second between the short circuiting starting and then eventually the circuit breaker stopping sending energy, something in here could blow up, like a little fuse or something, and I would never be able to switch and do maintenance on one of these boards. I think I would just buy a new one in that case, but I don't want to do anything silly, so I'm taking off all the energy from this. So now let's zoom in and try to find the little ground thing. So it's this pin right here, that's the ground. We want to connect one of the sides of our button to the ground. The other side of the button, we want to connect, oh, there is another ground here. There are two grounds. There is a ground here as well. And then the other side of the button, one goes to the ground, the second goes to one of these inputs, and we have little numbers here. that you can barely see because my camera is not focusing right, but you can barely see these numbers here on the board. For instance, the number 7, I think, is the easiest to see because there's less stuff going on. So we're going to connect one piece to the ground, one piece to the number 7, maybe. Or we have a few options here. I think it goes up to 12. Oddly enough, it does not start with 1. Ports 0 and 1 can be used as, in this case, inputs. Ports 0 and 1 can be used as inputs, but they are also used to communicate with the computer. That means that if I were to use one of these ports, I would have to not communicate with the computer via USB. That would be out of the question. And I could power this board with some other power source, and then I could do things like speak MIDI with a MIDI cable or have some LEDs and buttons connected to the board, but I couldn't talk to the computer. So ports 0 and 1 are these ports here to the right of the ground port, and those ports are reserved. I think there is like TX and RX and RS and all these ports. They are ports that are used by the computer communication. So we are not going to use those. We are going to use ports starting from 2 up to 12. And because we only have 4 buttons in the end, we are probably going to use ports like 2, 3, 4, and 5. Or maybe to have a little bit of space in the board, we are going to use ports like 5, 6, 7, and 8. Or maybe we're going to jump a few ports, whatever. So yeah, let's cut some cables. Now we are actually doing hardware stuff. I wish I was better at this, okay? Let me start by saying that. Very therapeutic. How are you all enjoying this? So now we have a little bit of cable that we can, a little bit of wire that we can put on the button, and another little bit of wire that we are going to put on the Arduino. Ideally, I would be using a breadboard and connecting everything to breadboards, to the breadboard connectors, but we are going to do this straight on the board. That will be fun. I'll probably blow something up. Let's do this side first. As I said, I don't think that this side here matters. It may, but I don't think it does. So let's just twist this a little bit and get that in there. So I'm making it like hug the little screw in there, so it's always in touch. And I think that that is enough for this very hacky prototyping thing that we are doing here. Or you know what? I may just get a screwdriver and screw this little guy in. Yeah, I'll get a All right, here is the screwdriver. Let's try to do this. It is either going to be very therapeutic or anxiety-inducing for me. And I know that I should put it in such a way that when I am screwing the screw in, it is going to tighten the connection, not loosen it. All right, there it is. Can you see that? No, it's not there anymore. There it is. Can you see that? Great. Oh, stay there, please, will you? Great. ASMR electronics here. All right, we have a little cable in there. Great. Rinse and repeat. And now you may be wondering, why would you do this project? What motivated you to do this project in the first place? I know you are all thinking that, so I'm going to answer. 2 reasons. First, I thought it could be fun. And it is fun. Second reason, there is, reason 1.5. It is cheaper to do this kind of project than to buy a MIDI controller. Typically, well, not in my case, because I had to spend money with like the multimeter, and a multimeter is more expensive than an Arduino board. At least that one was. Not by much, but it was more expensive. So all in all, I probably spent more money than I would have with just buying a very cheap used MIDI controller. But the second and probably the most important reason is that there is no MIDI controller that is exactly what I want, that has exactly the number of buttons I want, that has exactly the number of expression pedals I want, that has the form factor I want. So the real reason why I'm doing this is so that I have control and that I have exactly the kind of MIDI controller that I always dreamed of. So that's my real reason. Now for the most difficult part of this thing, I'll have to plug things into these little thingies, these little pieces of metal. I will have to plug things in there and make sure that they're not touching anything else but the thing I want them to touch. That will be hard to do without a breadboard. I wish I had a breadboard. I would just like plug the thing in. Oh man. I think I'll get a breadboard for Thursday. But I mean, I had to go across town. It was a 2-hour bike ride, round trip, for me to get all these components. And they're only labeled on the top, because of course you would put this on a breadboard, right? So maybe I can just barely touch the thing. You will see me blowing up the Arduino board, aren't you? But maybe I can just touch it like this. Yeah. Yeah, I think I will be able to just touch the thing like this, and it will do, well, the thing is, maybe using the button will be bad for this prototyping situation, very hacky prototyping situation that I have here, because I will not be able to have 2 hands securing the wires in the right location and be able to press the button at the same time, am I? So I'm going to get a third piece of cable to pretend that I am pressing the button by just touching the terminals with the wire. And we'll write the code to make that happen, to pretend that we are pushing the button instead, and to read those inputs coming in. Unless you have better ideas. If you have better ideas, then let me know. Oh man, I made this too short. I can't hold it. I don't have a plier. Oh, a second plier. I do have it, but I don't want to go out and grab it. Great. Now I have a little jump cable here that I can use to wire the ground to number 7. So let's write the code for this. Now, okay, I switched to this camera and I was afraid that it would stop the audio, but it didn't. You still hear me. Great. So let's write the code to actually use the push button. So the pin mode of the port number 7 here is going to be, it's an input, but it's going to be an input that is using an internal resistor here on the board that is called a pull-up resistor. And that is to guarantee that when the port, when we are not short-circuiting, because when the button is pressed, we press the button, it is as if we are connecting the pin to ground. And when we do that, the output would be a number 0. But when we are not connecting, the pin is set to be floating. A floating pin can be 0, it can be 1, it can be off, it can be on, we don't know. It's in this undefined state. So if I just said input, it could be floating into this undefined state. But the Arduino board comes with a pull-up resistor inside the board. And what this pull-up resistor does is it drains the energy from the pin. So, or not drains the energy. Yeah, well, I suppose, yeah, that's what it's doing. So if it's not connected to the ground, it is, this pull-up resistor is going to be draining the energy from the pin, and it is going to keep the pin at 1. So if the wire is not connected, we get a 1. If the wire is connected, we get a 0, which is probably the other way. It's the opposite of what you would think. You would imagine that when it's on, it's 1, but it's the other way around. When it's on, it's 0. So that's the pin mode for pin number 7. Then on the loop, we are not going to just delay stuff and whatnot. No. We are going to need a variable to say what is the current state, or actually the previous state of the button. So let's say that it starts with a 1. 1 being it's not pressed. So if we want to do a digital read of port 7, if that is equal to 0, so the button is pressed, and the previous state is equal to 1, I guess I will do it the other way around, so that it reads like previous state, current state. Maybe I will even have a variable for this. So the current states, oh, well, the current state is the digital read. Okay, so, and do I say 0 and 1, or do I say high and low? I forget. So let's look up for Arduino button. Really? No code? Oh, here is the code. Let's see. Digital read, yeah, I will use high and low. So if the previous stage is high and the current stage is low, that means that the button is pressed. Button has been pressed. And if the button has been pressed, we are going to send that MIDI message. Note on. No delay. And let's do the opposite. So a button has been released if the previous state was low and the current state is high. If the button has been released, we'll send the little note off message. No delays needed. And finally, we need to remember that the previous state is now equal to the current state, so that when the loop goes back around, previous state will have the correct value. Suppose that this is all we are going to need. Oh, I will not be able to upload because this is not connected to the computer. I wonder what happens if it says, like, remember to connect your board. Yeah, I couldn't find a board. And this, the list of boards, the ports, nope, does not contain the Arduino anymore. Oh, the old problem of Arduino, of USB ports being 4-dimensional. And we are back. Annoying as fuck, this thing. Yeah, it is when I connect the Arduino. I don't think it's when I transfer, it's when I connect it. So I think I know how much you lost of what I said. And let me recap. So we can ignore this warning. That's what I was saying before. We can ignore this warning because it's just a problem of this variable being an integer and this variable having to be this value that is an unsigned integer of 8 bits. And that's a smaller kind of value. So if we had big numbers here, we could be losing information. But we don't have big numbers. We know what the sizes of the numbers are. So we know that we are not losing information. So this is a warning that is safe to ignore. I'm just checking again in OBS that you still hear me. Great. Yeah, so we wrote this program together before I plugged the board. So I think that the audio was still working back then. So everything that I explained about the program you got, right? Yeah, let me know if you got the explanation of the sketch or the Arduino program itself, because I think that I did that before I connected the board, so I think you should have gotten that. Let me know if I need to explain that much again. But after I connected the Arduino, I transferred the program, so that warning explanation I had to redo, and I redid. And I uploaded the sketch to the board, so that much is done. And we are ready to test our program. So is the logic of the program making sense to you all? Okay, you got it. Great. And Rainbow Grid, I hope I'm pronouncing this right, is saying, how did you establish a MIDI connection with Reaper? Are you using a USB serial app or something? I want to try this myself. Which Arduino is the best these days? For this kind of project, you want to go... Oh, it was off for 10 or 15 seconds. Great. It was just when I plugged in the board. Right, so in the beginning of the stream, I explained this more in more detail, but in essence, you want Arduino boards that can act as Age ID devices, Age ID like this. They are Arduino boards that can act as keyboards or mice or mouse or touchpad, and also as a MIDI thing. And if you get some other kind of board, then you will be able to still speak using the serial port with the computer, and then you will have to run an app. There's an app called Hairless MIDI, and you have to keep this app open at all times when you are working with the Arduino. So if you have an Arduino that does not speak this protocol that is a USB MIDI or USB keyboard or USB device, if it does not speak that protocol, you have to have this app open, and the app will make the bridge between the serial port in the Arduino with the MIDI stuff in your computer. But that's not cool, right? You have to open up this app and you have to configure everything. So if you only have a board that does not have that and you don't have $15 to spare, then this is a good strategy. But I really recommend that you go with the Arduino Micro. That's the one I have right here. But you can also get the Leonardo, you can get the Teensys, that they are not Arduinos, but they are similar in functionality and they're prototyping boards like this. So those are the ones you can get. You can also go to the MIDI USB library documentation, and somewhere in there you're going to find a list of devices that work well. Or you can look at the board if you want to go into the specifics. If you're buying something that is not made by the Arduino company, you can look up the version of the AVR core, the version of the SAM core, SAMD core. I don't even know what most of these are. I just went with the one recommended by the library. And this is definitely important. The ATmega32U4 is the microcontroller, this little board here. That's the one you want, not the ones that come in like the most common Arduino, which is the Arduino Uno. It's the first one on the page. That's no good. That's not going to work. Nano, no good. Leonardo, okay. Micro, okay. This, I don't even know, but probably not because it's a Nano. Yeah, and Duo, I think that one is going to work for this kind of project. Yeah, and a prototyping board. I will get one of those. Right, so now I only use the old Uno. I will get the new Arduino Micro. Yeah, if you only have the Uno and you don't want to get the Micro, you can use Hairless. I don't recommend it. Just go get the Uno. It's like $16. Probably. That's how much I paid at least. Right, so everything is wired. The program is running. We have Reaper open. Reaper does not see the Arduino. It's disabled. That's cool. We can enable it. I don't think I have to do that every time. It's probably just because I closed Reaper in a weird way, or maybe the Arduino was disconnected in a weird way. I don't know. I hope I don't have to do this every time. But the Arduino is connected now. Now let's go to our MIDI logger and definitely turn the track on for recording and arms for recording MIDI on all channels. And then that's the moment of truth. I will get my hacky little jump cable. I will connect the ground to port number 7, and we should see some messages showing up on the MIDI activity log. Let me make sure that I flushed. So we should be able to see messages coming through. Moment of truth, my heart is racing. Let's see. Would you look at that? It did not work. It worked. It worked. Success. All those MIDI notes were sent using this cable. If that's not fun, I don't know what is fun. This is a lot of fun. I love this. I have to go now, but I hope you keep the video online so I can go ahead and watch it when I am back. Yes, you will be able to watch this later for the rest of eternity while YouTube exists. But that's it for now. I see you again tomorrow, and I will not be working on this project. We will be working with Aria from IDDQD Sound on orchestration. We will be working with a library with strings and woodwinds, brass sounds, that sort of stuff. And we'll be talking about composition. And yeah, you saw the best moment. We got some MIDI messages. So yeah, tomorrow I will be working with orchestration and composition with Aria. And then on Thursday, I will be back into this. And I think I will be doing this on Thursday and Friday, and I think it will be over because honestly, this project is rather small and we did most of the heavy lifting already. There is only the pedal still left to work with, and then we can decide which messages the buttons are actually going to send, but that's probably going to be relatively quick. Yeah, so thank you all for being here, for supporting me in all the different ways that you do, and I will see you again tomorrow for some orchestration and composition. Yeah, let's wrap this up. I am clicking on buttons because I don't have my MIDI pedal board to switch scenes in OBS, am I right? All right, see you tomorrow, bye.